Hi guys, so now I'm Yongjae. I just run an experiment which is time versus temperature graph at outside. The aim of this experiment is to estimate the optimum temperature for a reaction that we run to get an optimum temperature for that. So the data we get is as following. So we get what we measure is time versus temperature. The temperature is our result, and this is my manipulated variable. So at 7 a.m. I measure the temperature at outside, which is 49 Fahrenheit. 9 a.m. is 57 Fahrenheit, while at 11 a.m. I get my temperature is 71, and 12 a.m. is 75 Fahrenheit. So due to the equipment malfunction, we didn't get the value for 8 a.m. and 10 a.m. But we need the result for these two, which is 8 a.m. and 10 a.m. So now we have a method to get the temperature, to estimate the temperature at 8 a.m. and 10 a.m., which is the traditional method is to use normal interpolation, which is 8 minus 7 divide by, because 8 is lying on the 9 and 7's the middle of that, so we use normal interpolation. So this is what we want to find, which is I label it at x. So this is 49, 57, negative 49. So now it's just normal mass. This is 1 over 2. Then this is 49. This is 8. So we can get our reading as this shifted, and this will be 4 plus 49, which is 53. So this 8 divided by 2, so will be 4. 8 divided by 2. So okay, now we estimate the temperature at 10, which you use the same method. 10 minus the small one, the big one minus the small one. This is what we want, which is 10. 11 minus 9, because it's lying on the middle. Same method will be 57 divided by 71, 57. So 1 over 2 x minus 57 will be 1. Okay, so will be shift it will be 7. X minus 7, 57. Our x will be 64. Okay, 64 degrees. But this is what we get from the interpolation.
My name is Hui Ying, and just now my friend Yongjae has talked about the experiment of performing the calculation of time versus temperature. And just now he uses the traditional method to find the points for 8 a.m. and 10 a.m. using the interpolation method. And now I'm suggesting the second method, which is Lagrange interpolation. So Lagrange interpolation is the reformulation of the Newton polynomial that avoids the computation of divided differences. And this is the general formula of Lagrange. From the formula, we can see that for Lagrange interpolation, it is taken the consideration of all the points in the experiment, which is 4 points. And now we have to find for 10 a.m. For 10 a.m. is between the 9 a.m. and 11 a.m. And using this formula, we have fx, x equals to 10, and x naught, we can assume it to be 7 a.m., x1 9, x2 11, and x3 12. So substituting all the x values into the general formula, and fx0, fx1, fx2, and fx3, we can get the value which is 64.3. So from just now what Yongjae performed, he get the value is 64. And the percentage error that we get is 0.005%, which is actually very small. So we would suggest that Lagrange interpolation would be the more accurate method to be used, since it is taken care of all the points in the experiment.
Okay guys, my name is Zhao Yi, and now I will continue to explain about the Matlab solution in our group assignment. So now later I will compare the result with the Matlab solution. So now I will show one by one step how you can type in the script file, and then you can get the interpolation at 10 and the desired value. Yeah. So firstly, we let time equal to x. So we write, firstly we open the script file and then we write the s equal to open bracket 7, 9, 11, and 12, and then we let y equal to temperature and 49, 57, 71, and 75. And then we know according to the title, we want to estimate the temperature at 10 a.m. The value is how much? Yeah. So we write S in and then equal to bracket 10. And now I will show you the inter P1 formula to get the interpolation value. So temperature equal to inter P1 S Y in S in. So by this one solution, we can get the solution after you run test. But now I will show you how you can plot the graph in the Matlab. So now we try plot, and then S, Y. So S is our time, Y is the temperature in degree Fahrenheit, and the last one is we put some color to, we put as minus O. Now we cross the bracket. So after that, you set this one in set the file name as for example, we set as group assignment. In N file. So and then we just need to run. After run it, we get the interpolation. Value, the interpolation temperature at 10 a.m. according to the title is same as the just now my friend Yongjae said is equivalent is 64. So this means by using the Matlab, we can approximate get the value. So, but now I will show you the sketch graph. So in Matlab, later we will get something graph like this one. Yeah. So we just assume this one is the linear interpolation in our Matlab. Because this one is a linear interpolation solution. And just now my friend Hui, she has shown us the Lagrange interpolation. According to the interpolation, he get the value is interpolation equal to 64.3. So after that, we compare the percentage error deviation. Yeah. So in our test, we only have very small 0.4 something error, not error. Yeah. Just the significant a bit the difference between. But this is because Lagrange interpolation is more Lagrange interpolation is more accurate. Yeah, because he get all the 4 points inside the formula. Yeah, so we can get the 64.3. Yeah, so this is our good assignment. Thank you. Okay guys, now I will show you just now what I like step by step in the Matlab solution. So firstly, yeah, this one is the S integral, temperature, block. Now we add on the S label, Y label, title and grade on. Yeah. So just now I set my name. The file name is group assignment. After comment, we get the temperature interpolation is 64. So I will show you the this is the graph test I show you in the whiteboard. Yeah, you can see this one is here is, so we assume here is all the linear interpolation. Yeah. So by using the Matlab solution, we know that we can get the approximate correct value. Yeah, around very correct compared to others method. This is 64. Yeah, compared to other method. This is more approximate. Yeah.